So in the previous example, we did a demonstration of what MPLS traffic engineering with node protection, I mean with link protection, and in this particular case, what we're going to do is we're going to use it for node protection. So let's go ahead and erase the tunnels that we created here. Get rid of all this. We'll just get rid of all this here. Get all that, all this. Get rid of it. Get rid of it. Get rid of it. Get rid of it. Okay, so in this particular case, what we're going to do is we're going to take a tunnel and we're going to configure it a tunnel to router 10, and we're going to go from the path we're going to end up taking. We're going to take it from 6 to 14. Actually, we're going to go to 6 to 7 to 2.8 to 10. And that's going to be the path of our tail end and our head end here. So we're going to go, our head is here and our tail end is there. Right. So what we're going to need to do is in this case is that because we're going to be doing node protection and we're going to do it for protecting on router 2, we're going to create a tunnel between. So instead of terminating it to what was our, so this is going to be our PLR like we discussed in the last video here, the point of local repair. Now, last time, our merge point was the actual next hop router of the traffic, which was when we did it to router 5, it was router 8. Actually, you know what? We're going to just go ahead and do a tunnel between router, we're just going to have it following that same IGP path. So we're going to have it going from 6, oops, that's not what I wanted. We're going to have it going from 6 to 7 to 8 to 2.5. Right? And so we're going to keep the same terminology. We're going to have our head of the tunnel here, right? And then we're going to have our tail of our tunnel here, just so we can keep the example similar to what we did before with the link protection and node protection, so you guys can see the differences of the configuration. And then we have our PLR here. Now, last time when we were doing the link protection, our merge point was router 8 because we were looking at this link here failing, and if this link failed, traffic rerouted through 14 to 2 down to 8, which was the meet point between our two tunnels, our regular tunnel between R6 to R5, and then our tunnel between R7 and R8. And in this particular case with node protection, what we want to do is, since we're going to be protecting on a failure of the actual node at router 8, our merge point is actually going to be router 2. So what's going to happen is on router 7, a tunnel is going to be created to terminate at router 2, and it's going to be bypassing router 8, protecting against this link here. This link here. Right. So we're going to just modify what we did already before. So we're going to keep the configuration R6 here. So we still have the tunnel between R6 and 65. The difference that we got to do here is that under the Fast-Reroute, we need to actually specify that we want node protection. So we'll do this here. It will do Fast-Reroute, and then you have to do the node protection. All right. So we're good to go on there. So now on our PLR, which is router 7, we're going to need to create another tunnel. We're going to shut down the tunnel that we created on router 7 that goes to router 8. Just show you guys that there is a difference. So we're going to shut that down. And what we're going to do is we're going to create another tunnel. We're going to call this tunnel 72. 72. And on tunnel 72, we're going to go ahead and do the regular IP unnumbered, loopback 0, MPLS traffic engineering tunnels, MPLS tunnel mode, MPLS traffic engineering, destination, Tunnel destination is 10.0.0.2. And then uh, tunnel MPLS traffic engineering path option 1 explicit. And we're going to call this avoid node R8. So that path hasn't been created yet. Tunnel 72. So that's the basic configuration that we need for that to work. So we need to configure our explicit path, name, avoid node R8. So like I said, the difference between link protection and path protection is that instead of putting the IP address of the physical interface that is connected between R8 and R7, we're going to put the actual loopback address of R8. And so my tunnel should come up here. Now, another step that has to happen is that on the interface between R7 and R8, I need to specify that that tunnel is a backup tunnel. So if I do a show IP interface brief, show run interface gig 3, and we're going to go ahead and just delete this, and we're going to change that to 72. So we should have a session come up, and then we should have a fast reroute entry already created there. Like traffic engineering fast reroute database, and you notice that 65 is being protected on by 72. So in this particular case, let's see where 72 tunnels went. So show MPLS traffic engineering tunnel 72. So the path that it's going is going to be going from 7 to 14 to 2 to 2. So this time the path went from 7 to 14 to 2. And this is our merge point here. So, like I said, the difference is being now we're completely avoiding router 8. Last time we were actually allowing router 8 to be the merge point with the link protection. So you were still going through router 8 even though the link failed. But in this particular case, our merge point is going to be router 2. So now when this link fails, all traffic should completely avoid router 8, and you should actually come out on the tunnel there. So let's look at this. So let's look what the trace route looks like now. Trace route 10.0.0. Really? .5. And that's the explicit path that we labeled earlier. We're going from 7 to 8 to 2 to 5. So 7 to 8 to 2 to 5. And what we're going to do is we're going to shut down that interface on gig 7. Gig 3, we're going to shut that down. And now we should be rerouting going through the new tunnel. Now, we're not having any crazy insane hops happening here because of the fact that our meet point is still going to be at the end of our tunnel. It's just that we're rerouting through router 14 using the TE tunnel label of 32. Once 20424016. Once that label goes, it's going to pop, and then it's going to pass the label 32, which is the original TE tunnel, which signals it to go to router 5. So that was pretty much what node protection is, and that's what link protection looks like. To show you guys the differences of how that's operating, and let's go ahead and recap. We have our head end and our tail end of our original tunnel, which is between router 6 and router 5. On our core routers, we have our PLR, which is our point of local repair, which is router 7, who is going to build a tunnel to the next top node. So instead of being the next top node, it's going to be the next top of the next top node, which would be router 2 in this particular case. We're going to have a tunnel that terminates there. We're going to be saying, hey, we're going to do tunnel protection. Actually, I wonder if the load protection would actually still work. Let's test that out. We can add it. Interface tunnel 78, no shut, and then interface gig 3, MPLS traffic engineering, backup path 78, backup path tunnel 78. I'm kind of curious to see if it'll reapply. RIP interface brief. Let's see. Traffic engineering. Traffic engineering, fast reroute. Yeah, it's not because the tunnel. Actually, let's see. I should technically be able to use this for link protection. Oh, because of my head end tunnel, I'm actually saying on my head end tunnel, I'm actually telling it that I don't want link protection, that I want node protection. So if I went back and changed this tunnel 65, no MPLS traffic engineering, no tunnel MPLS traffic engineering fast reroute, and then I do a tunnel MPLS traffic engineering fast reroute without the node protect, it should trigger to try to use the link between 7 and 8. Yeah, so there it is. Oh, no, wrong router. There it is. Huh, interesting. Let's see why that's it's happening. Let me re-optimize the tunnels here. Huh, that's interesting. I should have been able to use database. Should be able to use that. Let's go ahead and shut down tunnel 72 and see if that brings up the other one. Yeah, I guess for some reason it won't let me do it on both paths. I think you can only have one backup path. I think that is one of the requirements for the TE tunnel with local repair. So that's why when I shut down tunnel 72, 78 came back up. And if I go back and do it the opposite, tunnel 72, I shut, no shut, and then go to tunnel 78 and then shut that down. You see that it came back up to use tunnel 72. And now we're doing node protection. So you can only have one backup path, but that's essentially how it works. Your PLR in your MP, the PLR is going to be the ingress point of your fast reroute tunnel. Your merge point is going to be the egress point of the T tunnel, which should be the same point of the exit of your actual, the same it's kind of hard to really. So you want to make sure that your merge point is the same exact point to where your TE tunnel would be going through in case of a link failure or a node failure. So if router 2 wasn't in there and I tried to do a TE tunnel to router 14 to protect against that node failure, it's not going to work because my merge point needs to be. Actually, I could have put a merge point here as well, and no, actually I couldn't because the original LSP does not go through router 14. So if I try to put one on router 14 and build a tunnel between there, you'll never see that tunnel be used because 14 was not in the path of the original LSP. So that's something to keep in mind when configuring this. But that was a brief example of what MPLS fast reroute, MPLS-TE with fast reroute on node protection looks like. All right, if you guys have any questions, let me know. Thanks. Bye.